Hi everyone, today I'm going to do chapter 4. But before that, I need you to have lecture note with you because it's going to be easier if you want to catch up with my slides here or if you want to revise on your own. Today's topic is force. So what is force? Force is what holds everything together, isn't it? Force is something that causes an object to move, to accelerate, to rotate, or even what makes an apple fall from a tree. In this chapter, we'll have two subtopics, but I will only cover the first part, which is the introduction of force and how to draw these forces on a diagram. Force is categorized into two, fundamental and non-fundamental. Fundamental is what governs our universe. These four fundamentals are electromagnetic force, which is the one that causes electron, proton, different charges attracted to each other. And we have a weak force, interaction between subatomic particles. We have strong force, the force that causes the tiny nucleus stay together. This is the strongest force of all. And the last one, gravitational force, is why our planet stays on its orbit. You're going to learn this fundamental throughout semester 1 until semester 2. Whereas the non-fundamentals are the contact force, the force that involving the actual touching. You're going to learn this today. This is our main focus. Force is a vector quantity. It can be represented by an arrow or a coordinates. But be careful. Student tends to make a mistake by not drawing the tips of the arrow there. So be careful. The unit is Newton or kilogram ms-2. The non-fundamental forces are these 5 basics: weight, tension, normal, friction, and also the external force. So you can see from the picture here, you have a different forces involving a physical touching. Now, let's go to the weight first. Weight is a force that exerted on a body under gravitational field. The equation is weight equals to mass of the objects times the g at the location you measured. For example, we use g of Earth at sea level is 9.81 meter per second squared. So it depends on where it is measured. That means your weight on top of the Everest would be different than your weight at the sea level, isn't it? Basically, you'll be a slightly weight less if you are sitting on the top of the mountain because g value would be just slightly smaller there. Next, the direction. Remember, the weight always pointed downward. Okay, if you have look at the example here, the first example where object sitting lies on the horizontal surface, the arrow still pointed downward. And where the example 2, where you have an inclined plane, the W or the weight, direction of the weight always pointed downward, which is pointing to the center of the Earth. Now, let's try these questions. You have two same objects, but sitting on a different planets. Let me give you, let's say, G value for Jupiter is way greater than G value of Earth. How much there are weight on this scale? Correct. The weight on the Jupiter would be greater than the weight on Earth. Why? Because remember, mass are the same, but the G are different. The second one is the tension. Tension is a force exerted by a string, cable, or chain on another object. The direction always opposing the loads. So in this case, we have the first example. The load is here and you try to move it to the right. That means the tension should always to the right. And what about if I have two objects here, 5 kilo and 9 kilo? So for these two cases, means you have two tensions drawing. Okay? Two tensions drawing should also opposing the load. Ataupun kita panggil melawan beban. So the T1 is due to the first load, the T2 coming from the second load. But you have to remember, if we have a smooth pulley here, okay, remember smooth pulley, and they are connected using the same string, so they have the same value of tension. The third one is the normal force, also known as a reaction force in other books or another reference. Okay, the force is exerted by the surface to the contact object. So if you have a surface and you have the object touching each other, there must be a normal or reaction. The direction always perpendicular to the surface. For example, I have a horizontal surface, 90 degree to the surface is upward. So this is my end drawing. What about if I have a wall or a vertical surface? So in this case, I'm going to replace with R because I'm going to use a reaction instead of normal. So the 90 degree or perpendicular to the surface is this direction. And the last one, let's say we have an inclined plane, the reaction should be 90 degree to the surface. So this is our surface, perpendicular to the surface is this way. So this is our reaction. You have to be careful for a hanging object. Okay, you hang something up, there is no N or R because it doesn't touch any surface. The fourth force is the external force. This is the easiest one because you just draw the force based on the pulling or pushing. Okay, let's see here, you have a pulling force that way, or let's say you have a pushing force of the patient that way. The last one, the frictional force. This is the force that resists the motion of one surface relative to another which is in contact. The direction should be opposing the motion. So if you like to see example, this is the first example. You try to move this object to the right, even though there is no movement, but because this is a rough surface, there must be a frictional force causing it to opposing the motion. And let's say I have an inclined plane here. I'm trying to pull this object with the tension T upward. So my frictional force should be opposing the motion that way.